Welcome you all. So here we are going to discuss the important disorder that is albinism, which is an autosomal recessive disorder. It is an inherited deficiency of enzyme tyrosinase, which leads to this genetic disorder, and the incidence is 5 in 1 lakh birth, and it is the inborn error of tyrosine catabolism which has characteristic feature we will discuss here, and it is autosomal recessive. As we have already discussed, most of the enzyme deficiency are autosomal recessive. So here you can see this is a albino family. This family in which all the siblings are suffering from albinism. This is a Coventry family, that is a Coventry albino family. Now, proud holder of Guinness Book of World Record for this. So, the biologically important compound that is a melanin, which is synthesized from tyrosine in a melanosome. Melanosome, which are present in a melanocyte, and these are the membrane brown bound particles within a melanocyte, which is present in a skin and which is derived from a neural crest origin. So, this melanin, which is synthesized from tyrosine in a melanosome, which is present in our skin. So you can see this is a melanocyte where you can see this is a nucleus, and these are the dendrites of this melanocyte, and these dendrites which contains a membrane bound particle. This is a cross section of skin where you can see these are the melanocyte and these are the dendrites of melanocyte, and in dendrites we have a melanosome which are responsible for production of melanin from tyrosine. So this melanin which is responsible for giving dark color to our skin. And here you can see this is a keratinocyte where there is a entry of melanin which is synthesized in a melanosome, and ultimately you can find your skin which contains melanin. So here we are going to discuss tyrosine metabolism in detail, how this tyrosine is responsible for giving melanin. So tyrosine it undergoes by the action of enzyme tyrosinase it gives rise to dopa, and by the action of enzyme tyrosinase it gives dopaquinone. This dopaquinone along with cysteine it undergoes polymerization, and here ultimately it gives a melanin red pigment. And this dopaquinone, again by the non-enzymatic action, it gives leukodopachrome. This leukodopachrome, again by the non-enzymatic action, it gives 5,6-dihydroxyindole. And this 5,6-dihydroxyindole, by the action of enzyme tyrosinase, it gives indole 5,6-quinone. This indole 5,6-quinone, it undergoes polymerization and it gives black color melanin. So red color melanin is because of cysteine, and the black color that is because of polymerization of this indole 5,6-quinone, and ultimately you will get a black color. So we will discuss what are the steps involved in the melanin formation. So first step is conversion of tyrosine to dopa. Tyrosine, as we all know that it is a phenolic OH group containing amino acid. Here only addition of OH group, one OH group which is added on the meta position. This is the ortho, meta and para position. So only the addition of OH group to the meta position of this tyrosine, and the enzyme required is a tyrosine hydroxylase or tyrosinase, which is a rate limiting enzyme, and the full form of dopa is 3,4-dihydroxyphenylalanine. The full form क्या है इसका 3,4-dihydroxyphenylalanine. Only the addition of one OH group on the meta position of this tyrosine, and ultimately the compound is a dopa. Okay, now again this dopa undergoes hydroxylation by the action of same enzyme, and this dopa by this second activity the compound will be there is no addition of OH group, there is a removal of hydrogen from this OH of ortho and meta hydroxyl group. And the compound become dopaquinone. The compound is a dopaquinone because of the this O and double bond. This is a compound that is a dopaquinone. Now this dopaquinone, it undergoes non-enzymatic conversion from dopaquinone to leukodopachrome. From leukodopachrome to leukodopachrome, where you can see there is a formation of bond. ये जो chain है ये यहाँ पे close हो जाती है. This chain which is a closed here, and after closing the compound become leukodopachrome. You can see the compound become leukodopachrome, and this is a non-enzymatic activity. Okay. Then this leukodopachrome again by non-enzymatic conversion it give rise to 5,6-dihydroxyindole. This compound which is the same as that of your indole group of tryptophan. ये जो compound है इसको हम बोलेंगे indole, and here there is a conversion of this leukodopachrome into the 5 6 5 at position 5 and 6. अगर मैंने यहाँ से काउंट किया 1 2 3 sorry 1 2 3 4 5, this is a 5 and this is a 6, 5 6 dihydroxy, and the compound is the indole. So it is a 5 6 dihydroxyindole, a compound which is formed here. Now again this 5,6-hydroxyindole by the tyrosinase activity, as we have seen in the second step of conversion of dopa to dopa quinone. Again this 5,6-dihydroxyindole get converted into indole 5,6 quinone. यहाँ पे OH ग्रुप था तो यहाँ पे हो गया O double bond, यहाँ पे बन गया. This is the same as that of second step conversion of dopa to dopaquinone. Here there is a conversion of 5,6-dihydroxyindole to indole 5,6-quinone. So this tyrosinase enzyme which is very important for the formation of melanin. Now here you can see as we have indole 5,6-quinone, it will undergo polymerization and ultimately there is a formation of melanin pigment. Okay. So you can see this is a melanocyte which is present in your skin. This is your layer of skin, stratum basalis, spinosum, granulosum, lucidium, where at the base you will find a melanocyte. This is the melanocyte, and these are the dendrites of your melanocyte. And here in dendrites you can find melanosome, which is responsible for production of melanin. सो मेलानिन कहाँ बनता है? मेलानोसोम्स के अंदर बनता है. Then this is the structure of your melanocyte which is present in your skin. It has a nucleus, mitochondria, Golgi apparatus, rough endoplasmic reticulum, and here these are the dendrites of your melanocyte, and here these are the melanosome, this small one melanosome, and here at the tip you can see that the release of melanin. यहाँ से melanin बाहर निकलता है. So in your exam, the case may come. A 12-year-old baby was brought by her parent to the pediatrician. She has a pale skin, blonde hair, and the baby was otherwise healthy and was feeding well but was unable to fix gaze. Why unable to fix gaze? Because of the this defective adaptation. यहाँ पे जो adaptation रहेगा iris का वो proper नहीं रहेगा. Because of that there is a defective gaze. Sometimes there may be a nystagmus also. So ophthalmic examination show a weight absence of pigment in a iris. Iris में भी यहाँ पे pigment रहेगा, retina में भी pigment नहीं रहेगा. Her two siblings had complete albinism, but the parents were normal. So this is the case. The case may be asked in your exam like this. So it is the autosomal recessive disorder, that is albinism, due to the lack of synthesis of pigment melanin. And there are the two types. One is the oculocutaneous and second one is the cutaneous. This oculocutaneous disorder, it has a 7 subtype. And out of that 7 subtype, the first one, which is a classic type of oculocutaneous disorder OCA1, and that is because of deficiency of enzyme tyrosinase, which is after the process of transcription and translation, the TYR gene responsible for production of tyrosinase enzyme, which is a rate limiting enzyme for the synthesis of melanin. So, what are the biochemical basis of melanism? Albinism. There are many possible causes for albinism have been identified. Out of that, the most common is the deficiency or lack of enzyme tyrosinase, which is the most common cause. The second cause may be decrease in the melanosomes of melanocyte. melanocyte में का अगर मेलानोसोम कम हुआ फिर भी अल्बिनिज्म हो सकता है. The next step may be, next defect may be impairment in a melanin polymerization. There may be a lack of protein matrix in a melanosome. जो भी material चाहिए मेलानिन बनाने के लिए in a melanosome that is a defective. There may be a limitation of substrate for tyrosine. There is a limitation in substrate that is a tyrosine जो हमें चाहिए. If there is a deficiency in that condition, there may be a albinism like symptoms, or there may be a presence of inhibitors of tyrosinase. जो enzyme tyrosinase है अगर उसको कोई inhibitor रहेगा, even though because of this condition there may be a albinism. Let's see one by one. First one is the deficiency of tyrosinase, which is the most common disorder, most common condition. Second one is a decrease in the melanocyte, decrease in the melanosomes of melanocyte. जो melanosomes है हमारे dendrites के अंदर, अगर इसका amount कम है या फिर there is a decrease in the melanosome in melanocyte, there will be no production of melanin from melanocyte. Then impairment in a melanin polymerization. अगर हमारे पास melanin तो बन गया, but if it is not undergoing polymerization to form melanin, in that condition there is a albinism. Lack of protein matrix in the melanosome. अगर melanosome में जो protein matrix चाहिए वो available नहीं रहा for the melanin formation, due to that condition there may be a albinism. And limitation of substrate for it is a tyrosine deficiency है, or there is a limitation of substrate because of any reason. Due to that condition there is a albinism. और inhibitors of enzyme tyrosinase. अगर इस tyrosinase का कोई अगर inhibitor रहा, because of this inhibition there will be no conversion of tyrosine to melanosome. So there are two types: oculocutaneous albinism and ocular albinism, where oculocutaneous albinism, which is characterized by the hypopigmentation of eyes, hair, and skin, while ocular albinism, it is characterized by hypopigmentation of only eye. Okay. So here you can see there is a melanin pigment which protect body from harmful radiation of sunlight. Therefore, albinos are more sensitive to sunlight and they have an increased risk of skin cancer. That is a melanoma. These patients are under risk of melanoma because melanin क्या करता है हमारी स्किन को यूवी लाइट से प्रोटेक्ट करता है. अब यहाँ पे मेलानिन तो अवेलेबल नहीं रहा है. Because of that condition, there may be a skin cancer. And lack of melanin pigments in eye may be responsible for photophobia. They are not able to tolerate light. Why? Because as we have pigment is there, because of pigment we can tolerate light normally. But if there is a deficiency of this melanin pigment, there may be a photophobia. So but there is a no impairment of eyesight of albinos. Normal eye रहेगी यहाँ पे, eye vision problem बिल्कुल नहीं रहेगा, but there is a photophobia because of lack of pigment. As in patients who are suffering from albinism, they are continuously exposed to UV light, and here this is your DNA which is exposed to ultraviolet light. Because of that, there is a opening of this double bond between A and T. It is adenine and thymine. The bond is open and this bond, this thymine, they form a dimer. ये thymine यहाँ पे dimer बनाएगा. And this dimer again responsible for forming a four-membered ring structure. This structure which is beyond repair, इसको हम repair नहीं कर पाएंगे because of the with the help of your DNA repair mechanism, that is UV specific endonuclease which is responsible for repair. If it is not repaired, such melanocyte get convert into the melanoma, that is a skin cancer. Albino patients are under risk of melanoma because of the formation of thymidine dimer, which is not repaired. Initially, it is in the form of nevus, and ultimately, the patient may land up into melanoma. That is because of continuous UV exposure in a albino patients. So here, what is the defect in this patient? There is a deficiency of enzyme tyrosinase, which is the autosomal recessive. We have already discussed the molecular basis of the condition and how you can manage. The only thing you can do is a sun protection. You can protect such patient by using some sun's protection. You have to wear goggles whenever you are exposed to sunlight, and you can use a corrective lenses that can be advised in a patient who is suffering from albinism. There is no cure that you can introduce melanin in your skin. The only management or only prevention is the sun protection and ocular management with the help of corrective lenses. So this is all about albinism and its disorder and what are the steps involved in a melanin formation. Okay, so please like, share, and subscribe. Thank you.